Hi, this is Jason Molesky. In this example, we'll take a look at interpreting a p-value. Calcium is a vital nutrient for healthy bones and teeth. The National Institutes of Health, NIH, recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers aren't getting enough calcium. Is this true? Well, researchers want to perform a test of the null hypothesis mu equals 1,300 and the alternative hypothesis mu is less than 1,300, where mu is the true mean daily calcium intake in the population of teenagers. Suppose they ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals that x bar, the sample mean, is 1,198 milligrams, and the sample standard deviation is 411 milligrams. Now, after checking that the conditions were met, researchers performed a significance test and they obtained a p-value of 0.1404. So in this problem, we want to explain what it means for the null hypothesis to be true, and we also want to interpret the p-value in context. Well, in this setting, the null hypothesis is mu equals 1,300. This says that the mean daily calcium intake in the population of teenagers really is 1,300 milligrams. So if the null is true, then the teenagers are getting enough calcium on average. Now, assuming that the daily mean calcium intake in the teen population is 1,300 milligrams, there is a 0.1404 probability, or about a 14% chance of getting a sample mean of 1,198 milligrams or less just by chance in a random sample of 20 teens. Recall that when we interpret a p-value, what we're saying is, assuming the null hypothesis is true, here are the chances we'd actually observe as extreme or more extreme than the one we saw. In this case, that 14% chance is pretty high, so I don't know that we have enough evidence to reject the null, but we'll learn a bit more about that later. For some additional practice with interpreting a p-value, try exercise 11.